Hello friends, this is my 12th lecture in Signal System series. My name is Nishtha Verma. The topic which I am going to cover in this lecture will be convolution of continuous time signal. Now, when we start a convolution topic, first question comes in our mind is what is convolution? In simple words, convolution is finding and integrating overlapping areas between two continuous time signals in which one signal kept stationary while time reversal of other signal keep moving from minus infinity to infinity. Means, suppose we are having two signals, suppose x1t and ht. This xt signal and this is ht signal. Xt signal will remain constant and we will take the folding operation of ht and we will keep shifting the ht signal throughout from minus infinity to plus infinity, and we will check the overlapping area. We will find the overlapping area. This green curve is showing that how the overlapping area, first it will increase, but as soon as the blue triangle will start going away from red triangle, the overlapping area is going to reduce. So before starting the numericals or derivation of convolution, first we should know what is impulse response. Suppose we are having system ht. If system is given, obviously we have to apply input and we will get certain output. We can also say that output is equal to nothing but xt multiplied by ht, which is system. If suppose in xt we know that various input signals in which impulse signal is one of the signal. So if in xt instead of input we are applying delta t, so definitely suppose it is first equation, it is second equation. When we put the equation xt in the value of second equation in first equation, you will get yt is equal to delta t into ht. And we know that if we take it as a unit impulse function, its value becomes 1 and it is ht. So yt will be equal to ht only. So the response which we get when we apply input as our impulse signal, that is called an impulse response. Response means output. Now derivation of convolution formula. The derivation which we do for convolution is for LTI system only. LTI means linear time invariant system. Here, suppose the input signal is impulse signal. So definitely the output we will get will be impulse response. Response means output. Because it is time invariant system, that's why if we do a little bit time shifting at the input side, definitely it should be visible at the output side also. If we multiply x tau d tau in input signal, it should come at the output side also. Now comes the superposition theorem. If we integrate the input signal from minus infinity to infinity, the same thing should come at the output side, that is minus infinity, and whatever the output expression is, it will come here. If you remember the impulse delta function property, here delta t minus tau is there. It means we can say that tau is equal to t. So because here because we are integrating with respect to tau, that's why t is constant. So when you put delta equal to t, it become xt. So xt become constant value, so we can take it out. And we also know that when we integrate impulse function from minus infinity to infinity, its value become equal to 1 only. So that's why at the input side we can write only xt. So obviously the input signal is xt, so the output, whatever this value is, it is your response. That's why we can write it as a yt is equal to, that is response is equal to minus infinity to infinity x tau ht minus tau d tau, which is nothing but a formula for our convolution. Now we will take a numerical based on convolution. So basically I will prefer a graphical method to solve the convolution numericals. As we have seen, the convolution formula is yt is equal to minus infinity to infinity x tau h t minus tau d tau. So in the formula, x tau is there and here xt is there. So we can replace t by tau. So if we have to plot x tau, it will look like x tau because it is negative exponential. So definitely it will look like this. And this is our tau axis. It is nothing but e minus 5 tau. Now next, because here ht minus tau is there, first we will plot h tau. H tau will be look like this only. It is nothing but e minus 3 tau, and this is tau axis. So because we need to find ht minus tau means we have to perform a folding operation over here. So h minus tau will be mirror image of this signal. So mirror image will look like this. This is my tau. Now if you remember, whenever there is a folding operation and we add something, t is constant over here. We can see that t is a constant over here. T constant can be negative or positive. So finally we have to find the overlapping area. So if we take t positive, so this signal will shift towards right. So it will look like this, 0, and t is a constant value. It is nothing but ht minus tau. You can ask why we are taking t positive only, because if we take t negative, the graph will shift towards left, and we know that when we shift it towards left, there will be no overlapping area between these two signals. That's why we are taking t only positive. So now putting the value in the formula, yt will be equal to, because here the overlapping area will come between 0 to t only. So that's why now our limit will be 0 to t. X tau is nothing but e minus 5 tau, and ht minus tau will be e minus 3. Instead of t we will write t minus tau d tau. We should remember here t is a constant value, so we can take it out. So it will be e minus 3t, and it will become 0 to t limit, and e minus, it will be, when we will take it out, it will be e minus 2t, 2 tau d tau. So when we integrate it, it will become 3t, and when we will integrate it, it will become 2 tau. Denominator minus 2 will come, and the limit will be 0 to t. So when we will put the limit, it will come minus 2, we will take common, it will become e minus 2t minus 1. So when we will open the bracket, we will get e minus 5t minus 2 will come over here, and it will become plus e minus 3t by 2. We can also write it as e minus 3t minus e minus 5t by 2, and ut we will place. Why we are putting ut? Because we know that overlapping area is present at the right side only, so that's why we are putting ut. So this is our answer. Now next numerical is xt is ut and ht is also ut. Again we will write the formula for convolution. Formula is yt is equal to minus infinity to infinity x tau h t minus tau d tau. So if we plot x tau will be look like, ut is simply like this, unit step signal, here tau, Now we have to plot h tau. H tau is nothing but same unit step signal, 1 magnitude tau, but here we want h minus tau, so h minus tau will be mirror image. It will look like this: 0, 1 magnitude, here tau. Now when we have to find add it by t, we know that if we take t negative value, there will be no overlapping. So we have to take t minus tau. T should be positive, then only it will shift towards right. Now this is 0 to t. This is tau axis. Here t will come. When we will find the convolution between these two signals, our limit will be 0 to t, because both our magnitude is 1 into 1 d tau. Now here we know that integration of 1 is nothing but a tau. Limit will be 0 to t. So it become, after putting the limits, it will be t, and ut we have to put because the overlapping area is present at the right side. So this will be our answer of convolution. Now next numerical is xt equal to e to the power at ut and ht is equal to ut. So again we will write the formula. Yt is equal to minus infinity to infinity x tau h t minus tau d tau. So here when we plot x tau, because it is exponential positive signal, so it will look like this. So it is e to the power a tau. This is tau value and this is 0 value. So h tau, when we draw, h tau is nothing but a unit step signal, so it will look like this only, and it is tau. Now h minus tau will be mirror image. 0, 1 magnitude will come here. Now because we have to take ht minus tau, so definitely we are going to take t positive value, because at the left side there will be no overlapping area. So my signal will shift towards this side. Suppose it is 0 to t. Here t somewhere it is coming. Now when we find the convolution between these two signals, the formula will be yt is equal to, limit is 0 to t only. So now x tau is nothing but e to the power a tau, and ht minus is 1 only, d tau. So when we integrate it, definitely e to the power at integration is e to the power a tau by a. Limit is 0 to t. 1 by a we can take common. It will be e to the power a t minus 1. So because the overlapping area is towards right side, so my final answer will be e to the power a t minus 1 ut. So this is my final answer. Now next is tut and ht is equal to ut. So again I will write the formula. Yt is equal to minus infinity to infinity x tau ht minus tau d tau. So if I will plot x tau, this x tau is nothing but a ramp signal. So it is look like this. This is my tau axis 0. So h tau will be same unit step signal 0, 1 tau. Now if I will take folding operation, if I will perform, it will become h minus tau. It will come towards left side. Now I have to find the overlapping area. So definitely I am going to shift it towards right side. ht minus tau, because at the left side there will be no overlapping area. So 0 to t. Here t will come. So when I will put in the formula, it will become yt is equal to, limit will be 0 to t. Instead of t, it become tau multiplied by 1 d tau. So when I will integrate it, I will get tau integration will be tau square by 2 and limit is 0 to t. So 1 by 2 I can take common. So when I put the limit, it will be t square, and because the overlapping area is present the right side only, so that's why I am going to write ut. So this will be my final answer. So the topic which I am going to cover in next lecture will be convolution of fixed length signal, because till now we have covered the signal which are going up to infinity, but in the next lecture I will cover for a fixed length signal, and as well as I will cover the convolution for discrete time signal. Thank you.